Okay, today we're looking at the Casio fx-991EX. I think the best calculator you can get for GCSE and A-level and beyond. So this is a question to do with Poisson distribution today. You're trying to find probabilities. And so we'll say the random variable x is distributed with a Poisson distribution 6. Okay, we won't go into whether that's real or not. This is very abstract at the moment, but as a particular distribution, the lambda is equal to 6. This would be the average rate that our variable is being measured at. So it'd be 6 per month, 6 per hour, 6 per second, really dependent on the scenario. Now we're going to have to find these particular probabilities. In context, this thing happens at a rate of 6 per whatever unit, and we want to find the probability that we'll get 2. So this is less than what we expect. You could call 6 what we would expect to get, kind of the average rate. And these are all equal to, and then we move to inequalities. So it's a quick way of doing this and a slow way. So we'll look at both. We'll go to menu, and you'll find these in the distribution, which is number 7. Press equals. And we've got a number of them here. You will use them. And we go down, and we find our Poisson at the bottom. For the exact equal to, we're going to be using the PD, which stands for probability distribution, and it gives us exact values. So that would be 2, and we'll go to variable, which is 2, and it asks us for the 2 bits of information. First bit of information is the x value, that's here, x equals 2. And the next is the value of lambda, in this case it's always 6 for us. And then we press equals, you will get the probability here that it is. So we could just make a little note of that to say we've already done it. 0.044. Okay. Now we're going to do it a little bit quicker if we've got multiple ones to do. So we'll go back to the menu system, go back into distributions and down to the Poisson PD again. And we're going to look at the list this time. It means we can use multiple ones at the same time. So we're going to answer questions B and C at the same time. So you can probably figure this out yourself, but the 2 x values we want are 7 and 10. So those are the next 2 questions, aren't they? I'm going to enter those in. And the Poisson value that we're going to get is in the next menu when we press equals. And we've set it to 6. We can change that, but we've set it to 6 previously and it's realized that, but we can just change that if we need. We'll press equals, and then what we'll have in our table are the corresponding probabilities for each one. So we'll just read it off. Probability of getting 7, which is closer to what we were expecting, was 0.138 if we round it. And then 10, which is further away than what we expect, 0.04 again, but on the other side. And away from 6 with 4 below that, and that's 4 above, right? So it's fairly symmetrical around the 6. Now we're going to look at the inequalities. The calculator has a better function when you're dealing with multiples. And we'll go back to the beginning part and select instead Poisson CD, which stands for cumulative distribution, which is going to add up multiple up to a point. Okay, so go into that by pressing 3. And we're going to go variable. There's no real need to do the list until we get later on. Perhaps for E would help, but we'll do them when we get to it. So in this case, the x will go in as 2, but it doesn't mean that it's exactly 2. When we're in the CD mode, it means it's going to be finding the probability when x equals 0 plus probability when x equals 1. And because it's including 2, we're also going to have the probability when x equals 2. It's going to do all of that, all of those three, because the calculator is preset to be less than or equal to. And the lambda stays the same. And we'll press the equals button once more, and we'll get the probability that we're interested in. So we add all of the probabilities from 0 to 2, and we get 0.061. Okay, we're doing great. The next one, let's go back to the menu system and down to the Poisson CD and variable. So we've got that ready. Now, at the top of this question, I'm going to talk about what's happening. We want to find the probability of values from 1 to 4, but not including 1. So we could write down 2, 3. It does include 4. So these are the probabilities that we're interested in. Considering that our calculator only deals with probabilities where x is less than or equal to a particular value, we can look at these as a summation of areas with things that are to the left. So what we don't want are 0 and 1. So we can do a takeaway sum. We can say that this would represent the probability that x is less than or equal to 4, because if we're trying to write it in less than or equal to terms for our calculator, this thing here represents 43210. And then we take away the bit that we've got rid of here, which is the probability x is less than or equal to 1. And if you do that takeaway, you're left with 2, 3, and 4. And we can do that individually on here by saying what is less than 4. Okay, it's this. And then we go back again and say what is less than 1. And it's this. And if we've written those down, we can do a takeaway sum. So let's now explore another way of doing that might be quicker. We'll go into distribution, down to Poisson CD, but this time we'll go to list. And let's say that we're looking to find 4 and 1. And our lambda is 6 in this case. Again, press equals, and we get our two values that we did individually earlier. See, the downside of using this is that you will only get them rounded to a certain number if you're trying to go on and use these. So I would recommend doing it this way and then taking them away manually. You can use however many decimal places you want. The more you use, the more accurate it's going to be. And finally, the more than. Remember, our calculator deals with less than or equal to. So how do we write this in a way that's more than, that's less than? Think about what it is. We write down the numbers that it is. It represents 8, 9, 10, etc. And that goes on. Okay. What we don't want is 7 down to 0. So if we just say that every single probability in this entire distribution is going to add up to 1, if we add them all up, then we can write this as 1 subtract the probability that x is less than or equal to, have you guessed it in your head? Yep, we want to get rid of 7 and below, right? So all we would have to do is go to our calculator, and I will go to proper distribution again and start again, Poisson CD variable, and we're looking for this part, the 7, and that's now in our calculator. Okay, that's now the answer part. We can go to menu, number one is that's actually really useful to remember. You'll be doing it a lot. Number one is calculation. Remember that the answer to this part is stored in our calculator. We could do 1, subtract the answer button down here, and press equals, and then we get our probability as answer to this question here. So that's how we find probabilities, and it's pretty much the whole range of things that you might be asked for, except for maybe there might be a few more of these less thans. Maybe I didn't do that, but this is it, and your calculator finds those probabilities for you. So if you've enjoyed this content or you found it useful, really love it if you give this video a like and consider subscribing. It's free and we'd love to have you around. See you in the next one.